Hello everyone, my name is Stacy Dawn and I'd like to welcome you to today's webinar, Simplify Capacity Management. IT teams are busier than ever before, keeping up with the day-to-day and supporting new business endeavors. There are more things to do and less time to do it all. That makes it hard to truly understand your IT capacity and even harder to prepare for future changes. In this webinar, you'll learn why IT capacity planning is still important, what you need to know to do effective capacity management, and how to make managing IT capacity simple. We'll even show you how to easily plan for growth in your virtual environment. If you have questions throughout today's presentation, please submit them via the chat box, and we'll do our best to answer them before the end of today's session. Before we get started, I'd like to introduce today's presenter, Jeff Schultz. Jeff Schultz is the Principal Sales Engineer of Technical Solutions for Capacity Management. He has answered questions for customers and tire kickers for more than 20 years. He has a wealth of experience in helping IT organizations get up to speed with their IT environment on their capacity planning and performance management objectives. Hi, Jeff. Thanks for joining us today.
Thanks for getting us started, Stacy. I appreciate the warm introduction. So just start out, if I can get the slide to change here. Start out with the agenda for today. I'm going to start out talking about capacity management, kind of describing what capacity management consists of and some of the values along the way. As the environments have changed, why has capacity management gotten to be so difficult? So I can provide some examples and some context around that. And then what TeamQuest has been able to help our customers do to make the process a lot easier and simple. So to start out with, I just want to describe a couple of instances where I believe capacity management was not done very well. If we look at this last year, Black Friday, I don't know, those that shop at Lowe's had a website issue and they were down for a period of time. Obviously, that affects revenue. Walmart also experienced some issues with their website on Black Friday. So, you know, if you think about some of those financial impacts with capacity not being done properly, it definitely affects the bottom line. Actually, my wife and I were up at the Mall of America in Minneapolis over Christmas, and we stood in line for probably 45 minutes. There were 3 customers in front of us to check out, and you know, they were doing things by hand basically. There were so many people that walked up, stood in line for a while, saw it wasn't moving, laid their merchandise down and left. Significant impact to Macy's. And just another example of capacity management that is important, and we'll cover this as we go through the presentation, but a top U.S. bank moved an application from their existing infrastructure and moved it to cloud, thinking that you know, they were going to be in good shape relative to, you know, the cost savings of going into the cloud. The reality is the cost of that move into the cloud actually doubled the cost of supporting the application. So these are just some examples of, you know, capacity management's value in terms of helping organizations do a better job to ensure they can meet their service levels. So if we look at the definition of capacity management for a second, there's basically 2 parts of it. One is the performance management aspect of it, which is the monitoring and reporting and the analysis and some tuning. That's basically the historical up to right now's view of the infrastructure and what's really happening. Where the value is really important is if I look into the future in terms of how my applications are growing, what directions are they going, what sort of capacity or the infrastructure do I need to have in place to actually support the environment. The trending and the modeling aspect of it are real keys, and that's where we want to spend our time today. So why would I lean so hard on capacity management? What is the real value? So there's a couple of major categories here that I just want to discuss. So, you know, the value of capacity management is around just flat out improving efficiencies. So being able to do more with less, optimize the environment in that respect, being able to reclaim wasted resources. So many times in In the self-provisioning aspect, there's a lot of wasted capacity out there, and even though it's sitting there, it still takes up resources and costs and licensing and that sort of thing. The other part of improving efficiency a lot of times is presenting some sort of a charge-based reporting. So, I mean, as we all, the simple example is if you go down to the cafeteria and the pop or the soda's free, you're probably going to consume more than you would if you had to pay for it, because you got to think about it. So, if you look at a cost-based reporting, that definitely changes behavior. The other part of it is if I understand my existing infrastructure and I'm looking at changes in the future, I can make investments just in time to ensure that I can meet those service levels. And another aspect of that is all around compliance and ensuring you can meet your service levels and other regulatory type of things. So the efficiency aspect of it is significant. Now, if I look at where I'm going in the future, I want to ensure that I can mitigate my risks. So, as I'm moving into new platforms, new infrastructure, that sort of thing, I can understand exactly what the new platforms are going to provide for me in terms of headroom and additional capacity. There's a lot of processes today that are manual, being able to automate those processes to, again, mitigate errors and those types of things. And then there's regulatory compliance that's obviously important to ensure that you can mitigate your risks. And the third part is just flat out being more agile. So as I'm introducing or replatforming into new environments, I know exactly the impact it's going to have to my infrastructure, how much headroom I'm going to have going forward. I can be a lot more confident that when I'm going to bring on new customers or there's M&A activity, I've got a much better idea of what my requirements are, so I can do those things confidently as I move forward. So from a capacity planning perspective, there's a number of areas that are very important in terms of being successful moving forward. So if we go back to kind of the progression of why capacity management has gotten so complicated, those of us that are as old as I am will say that go back to the 70s and 80s, you really were dealing with mainframes or monolithic type systems. The capacity planning was focused, dedicated, because every time I was going to add more CPUs to this thing, it was probably going to cost me $250,000 or more, so you wanted to make sure you wrung as much capacity out of those guys as you possibly could, and the planning and the deployment was actually in months. Then when we got into the 90s, the client-server architecture became available, and the systems went from tens of systems to thousands of systems, and so there was a lot more infrastructure that was in play that needed to be monitored and care and feeding to make sure that stuff was running optimally, and the deployment was days. I'm almost going to say weeks a lot of times because of the provisioning and that type of thing. And then we got into the more recent technology with virtualization, and as we all know, that's gotten a lot more complicated, and you're looking at tens of thousands of systems that make that process even more complicated. Although the deployment was very quick, there was a lot of waste from my experience in working with customers. And now that we've got the advent of cloud, all bets are off. I mean, there's a tremendous amount of moving parts, tens, hundreds of thousands of things when you start talking about the cloud instances and containers that need to be tracked, even though they can be deployed in seconds. The cost associated with cloud, because it's off-prem, is significant. So when we look at how technology has changed, it certainly has increased the complexity and the number of moving parts that are required to keep track of things. Now, if we go back to the roles, the people that actually did the capacity planning or do the capacity planning, back in the day, they were dedicated because of the cost associated with adding more capacity to systems. So they were dedicated, they really spent time, and they really understood the architecture of the system. And back then, in the 70s and 80s, there really wasn't the there really wasn't the instrumentation in the beginning to really understand to do that, so it was even more complicated. But now, in today's world, there's a lot of different roles that have their fingers in capacity management, but there isn't really necessarily the focus on true capacity management. So if you look at all of these roles from an enterprise architect all the way to a cloud architect and a service delivery manager, all of these people have some level of say will position as input into capacity, but there's not really a person that's really responsible for it. So when we look at some of the challenges around the capacity planning process, you know, the capacity planners that do the work today that are focused on those things are, you know, overworked just because of the volume of things that are out there that they need to keep track of. The other part of it is the skills shortage, you know, where there's a lot of guys like me that are getting put out the pasture that used to understand the underlying architectures and the effects of changes. So the skills are in shortage, and so then when capacity planning processes are done, a lot of times they're rushed and they're not necessarily accurate. And as we all know, if I don't provide accurate results, I start losing credibility. And so, you know, because of all of that, in many cases, there isn't really a good capacity management process that's in place, and so it's really not occurring, at least not very well, unless somebody, you know, moves an application to the cloud and it doubles. All of a sudden they look back and they start to really scrutinize what's really going on. So from a definitions perspective, I just want to talk about some nomenclature here so we're all on the same page. When we talk about traditional IT, it goes back to primarily systems that are on-prem, or they could be in a co-location. So you've got kind of the traditional systems. I've got all of the monitoring. I've got all of the insight into exactly what's happening there. And then we move to private cloud. Again, we still own all of the infrastructure. We still have visibility into the hypervisors and all of the mechanical parts that actually drive all of that. And so then when we move to cloud, cloud, as we all know, is, you know, the unknown up there. I just allocate resources and, you know, it's automatically there. So the cloud part of it is kind of the new dimension. But what I want to draw your attention to is when somebody talks about hybrid cloud, they're really referring to your internal cloud as well as the public cloud. So those two clouds basically are tied together with hybrid cloud. And if you look at the whole environment, which includes the traditional IT, that's really described as hybrid IT. So just when people are starting to talk about these different terms, I just wanted you to understand exactly, you know, what those things meant. So as organizations start to move applications from their private cloud or even their traditional resources, and they start to move those things into the public cloud, you know, there's a concept called lift and shift. So I have all of this infrastructure that supports an application, and I take that and I lift it up basically over and I allocate the same type of resources and I put them in the cloud, and, you know, things are wonderful, right? And they can be, but there's a cost associated with that. So what we promote is basically a lift, a trim, or an optimize, and then a shift. So to do that, what we do is we go back and we look at what the current business cycles are, what's really happening, and so I need to understand: is this an online process that runs, you know, on a daily basis during business hours? Is this a process that runs batch that's important that needs to be addressed? Or what are the business cycles that I need to be concerned about? Because I need to look at that data before I can actually do a capacity plan. The other part of it is, what is the resource utilization? What are those peaks? What are those valleys that I need to be concerned about? And what's a way of being able to look at all of that information? And maybe I take the 95th percentile or the 98th percentile, so I can take those spiky outlying behaviors and exclude that in the analysis. So using a percentile potentially would give me, you know, a better view of really what reality is. Then the other part of the analysis is those that understand cloud. There's a concept of on-demand resources, and then there's the concept of reserve resources. The reserved resources over time are generally cheaper because you're basically committing to a certain capacity, where the on-demand resources, depending on how you're using them, you can save some money because you just basically use that as you need to. But if you exceed what that agreement is, then they're actually more expensive than the reserved instances. So you need to make a consideration of whether an on-demand instance is going to be a better fit than the reserved instance. And then as I'm making this analysis and trying to move this to the cloud, what I'm also need to include is, as we all know, the infrastructure is not necessarily static, right? Everything continues to grow. So when I move it to the cloud, make that projection into the cloud with the resources, I need to consider some level of growth, because as we all know, it's going to grow, and we need to plan for that in our analysis. So when I look at the inputs into it again, in the solution, when we provide the analysis, I look at the interval. Is it the last 30 days? Is it last month, the Black Friday month, or Black Friday date range? Then when I look at the business cycle, is it weekdays? Is it business hours? I can certainly adjust those because they're important based on the application. And then in this case, I'm looking at a 95th percentile. Those are kind of the inputs into what I want to analyze. Then the bottom part of it is how much growth do I want to plan for? In this case, I'm looking at a 10% growth. I want to make sure I've got that much headroom. But then the last three selections on there are all about defining what sort of levels of usage do I need to set. And if the analysis proves that I'm saying, say, greater than 20% CP utilization, then I need to consider it a reserved instance, and I can do the same thing with the disk space as well as a network. So these are the inputs into the analysis that I want to review the existing infrastructure so that I can size it based on what I would recommend for the cloud. So in this next slide, it's a little bit busy, but on the left-hand side, you can see the existing infrastructure. And if you look at the first column where it says configuration, on that first line up there where it says T2 large, that would be the cloud size that I would deploy based on the current infrastructure configurations. But if I go back to the 95th percentile or the average, the allocation would be a T2 nano. In both cases, in the data here is internal, so there's not a lot of activity, but you can get the picture of whether I've got a lift and shift. I would go to a T2 large, and if I looked at the analytics and applied the 95th percentiles and the averages, you can see the sizes that I would allocate in the cloud. And then I also describe the reserved instances. In this case, there's just one system down here. The CE Linux 4 system has enough capacity, steady capacity, that I would recommend that as being a reserved instance. So, you know, when you look at all of this, it's, yeah, that's all nice, but let's find out what it really means. So we ran this analysis on some of our internal infrastructure here, and you can see that based on a lift and shift, I would be looking at $4.94 an hour. But if I did the lift, trim, or optimize and shift, I'm looking at 61 cents an hour. Well, that's pretty substantial by doing just a little bit of analysis. If I go back to one of the customers that we worked with, which I'll name, be nameless at this point, if their lift and shift was $18 and some change an hour, and if we really analyzed the infrastructure that would be required to support the application, we're looking at $3.27. So you can see like a 6 times savings there in terms of the cost savings by doing just some simple analysis when you make that transition. So when we look at a lot of organizations, and I've worked with many organizations, large and small, and surprisingly, some of the larger organizations I work with, they use They use some complex linear trending. So what they're doing is they're taking KPIs, key performance indicators like CPU, memory, I/O, network, and those different types of things, and they're basically looking at the historical data, and they're basically trending it out. If it exceeds a threshold, they consider that a capacity issue, right? So they're looking at some sort of a linear trend, and some of them are fairly complicated, but nonetheless it still isn't necessarily representative of how the infrastructure actually supports that. So what we apply is our advanced analytics, our queuing theory, to define, the behavior of the system. And so if you look at the chart on the bottom here, you can see the response time and basically the transaction rate, which is really the increase in the workload intensities. You can see how that line is linear to a point, but when you approach the red there, you start to see the performance really start to degrade. And so when you're doing the linear trending approach, you really don't know how close you are to the edge. And so what we've done is we've got a similar type of a chart here. So what we're doing is we're creating these bands, if you will, of performance, or available capacity, I should say. And you can see the green is linear. The lines in the green are fairly linear, but when you get to the yellow is when you start to hit that knee in the curve, and then when you go into the red, things are starting to really degrade. Now, the advantage of what we're doing here is we not only provide the colors for an easy way of being able to understand, whether you've got risk and that sort of thing, but the other part of it is we apply a score to it, right? So if I've got something in the green here that's running, say, 45, I'm getting close to the edge. Or if I exceed and I'm in the red, and I've got a score up here that's like 40 or something even higher, lower, that's like 10, I've got significant performance problems. So the colors is an easy way of really being able to look at your capacity, but more importantly, providing the score gives you the understanding of how good or how bad things might be, which is really important. So as I work with organizations, and I'm sure everybody on the phone is similar, when you look at the infrastructure, again, based on everything that's going on, there's no way that you can go and look at all of this stuff. So what we provide is the ability to be able to provide this automated analytics against the data. So that way you can start to look at an application, all of the infrastructure that supports that, and you can start to see the workload behaviors. If you look at a heat map, you can see when things start to get hotter and when they start to run cool. And so you can identify where you've got some potential risk based on some level of growth, and you can put the input into the growth and the analytics, so you can start to see when you starting to run out of capacity. So that gives you the ability to look at your total infrastructure, or a part of the infrastructure that might support an application. And once you identify that you've got some risk, then you can start to do the more interactive things. What am I going to do with the infrastructure to ensure I can meet those service levels? Do I need to add more? Do I need to add more logical CPUs to it? Do I need to add more servers in the tier? What do I need to do to support that? So in saying that, what TeamQuest is providing is a solution called Capacity Plans. It's an interface that basically makes it really easy to use. So you don't have to be what I'd call one of the long-haired rocket scientists to build models. And the accuracy is obviously the key. Again, as I described earlier, without some level of accuracy, you're going to lose your seat at the table. The other part of it is once I identify where there is an issue that I need to address, then what I need to do is it needs to tell me what I should do to resolve it, right? So the actionable aspect of it is key. So when you look at the ease of use, the accuracy, and making things actionable, what do I need to do to resolve the problem, benefits, the experienced capacity planners, they can do it faster, but more importantly, those less experienced capacity planners have a way of being able to generate models quickly, accurately, and support the business. So on the next page here is all about some of the different types of plans that we see organizations requiring or needing to do. So if I look at just the increase in demand, I've got this application, it's going to grow, and I need to ensure I've got enough capacity. Let's have this, and again, these are what I want to describe as guided workflows. So if I'm going to do an increase in demand, there's a series of questions it asks to give you the result, and we'll step through that as part of the demonstration. The other important one is the number of virtual machines. How many more virtual machines do I need to have, or how can what I describe a lot of time is turn the knobs. How many more logical CPUs, share weights, in reservations, and those different types of things can I tweak to ensure I can meet my service levels without having to add more capacity to the infrastructure. The next one would be just, all of our applications these days are all tiered, and they have a number of systems in the tier. How many systems or how many servers do I need to have in that tier so that I can ensure I meet the service levels and or the growth in service levels? We're all bringing new applications online, whether they're internal or whether they're external. I've got this application. I need to deploy it either on existing infrastructure or add it to other shared services. What's the capacity requirements to do that? I know there's new technology that's being developed and delivered all the time. So if I upgrade to that new technology, kind of as I described earlier, what is it really going to gain me, right? Am I going to really have to take advantage of that to beat my service levels? So just a quick sidebar with that. I was working with a government organization out in California one time, and they had this new application that they were going to deploy, and the vendor came in and said, you really need to buy this new hardware, and it's going to cost you $1 million to deploy it. And at that time, this prospect, we'll say, actually hadn't even invested in TeamQuest, but they were looking at our modeling technology and evaluating it. So we rolled our sleeves up, and in a short period of time, we were able to build a model that represented what their expected growth was going to be, and then utilize our existing infrastructure, and we were easily able to support the application growth for that next year with the current capacity or current availability of infrastructure that they had there. So they put off buying the new hardware for another year. They knew they needed to buy it, but as we all know, in another year the technology is cheaper, faster, and better. They were able to wait another year just by doing the modeling. So it's really key in being able to evaluate either existing infrastructure and or new infrastructure to understand what the capabilities really are. And then the last one is just the expert mode. So basically I come up with a whiteboard and I start drawing my own lines and figure out exactly what I want to do. So for those more advanced users, there's the expert mode that provides the ability to do some very sophisticated type of modeling. So from there, what I'd like to do is actually demonstrate how easy it is to use the modeling technology, our capacity plan solution. So the scenario that I want to describe is that I've got infrastructure that I need to grow it at 15% over the next 12 months. I need to plan for Black Friday, and I want during that time, the capacity requirements are actually going to double. And at the end of the year, I need to add 8 more VMs to the infrastructure. So what I want to do is just demonstrate, the use cases of that, and then actually show how easy it is to do that. So the screen that you see now is basically kind of the blank screen. And what I want to do is I want to click on a new plan because I've got a new modeling plan that I need to run. So I click on New Plan, and what it's going to do in this case, I want to do a planned increase because the first thing I want to do is I want to look at the infrastructure and I want to grow it 15% over the next 12 months. So I'll just click on Plan for Increased Demand, and at this point, what I'm going to do is I'm just going to grab the system, and I can put multiple systems in the model, but I just want to keep it fairly simple just for the demonstration today. So I'm going to look at this particular host, the CSX host, and I'm going to click on Next. Now, if you remember, I said I wanted to plan for the next 12 months, and I could change these to quarters or years and stuff like that. And then it's actually going to start in April, and I'm going to click on Next. So what this does is it goes out and looks at the historical data and picking a baseline, and those that are capacity planning people really understand what is the baseline that I want to use. Where do I want to start my projections from? So when I click on the select system time, what this algorithm does is it goes back out and looks at the historical data, and it picks basically the peak times for CPU and I/O. And so I can actually go back and change this if I want to a different time, but I'm going to leave it as it is because it's taking kind of the peak CPU and this bump in I/O here as opposed to taking one of the bumps in I/O at the end here. So I can actually define, it automatically defines or suggests what it believes is the best baseline is, and we've had some good success there. So I'll just click on Save. And so at this point, I want to click on Next. And now the other part of it is I want to be able to grow this at 15% annualized over the next 12 months. So I'll just add 15 to this, and I'll click on Next. So now what I can do is I can name the plan, and this is the marketing forecast for 2018. And I'm going to click on Save and Run. So this is going to go out, and it's going to pull the performance data and generate a model that looks at the next 12 months worth of activity based on the 15% growth. And I haven't done anything else outside of that. Now, when you look at this, I've got what seems to be some serious performance issues or capacity issues. So I'm going to click on Show Details, and it's going to show me that I've got one VM called this Sales CL Planner, and as well as this Armadillo instance, I've got capacity issues here. So I understand I've identified I've got an issue. So if I look at the advice, what is it telling me that I need to do? So the Armadillo system is telling me that I've got a CPU issue that I need to add more CPUs to it. And if I look at the Sales CL Planner system, it's telling me a similar type of thing. So it gives me some alternatives as to what I could do to alleviate the issue. So what I'm going to do here is I go back to kind of turning the knobs on the VMs. What I'm going to do is I'm going to add more capacity to these two VMs. To do that, what I do is I create an event, and I'm going to change the CPU machine settings. I'm going to create that event, and I'll just keep the nomenclature the same. Change that I didn't have the Armadillo aspect of it. I just had EMEA Armadillo, and that machine is the Armadillo machine here. And that currently has 4 CPUs. Now that guy was really getting throttled, so I'm going to go from 4 logical CPUs to 10. Now I do have the ability to change the reservations, the limits, and the shares, but I'll just leave those at this point. And I have the ability to change the time frame as to when this happens. So I'll just move this one out to June just to prove I can change it, and I'll click on Save. Now the other system, Sales CL Planner, was struggling as well, so I'm going to add more capacity to that as well. And I'm going to say I change my CL Planner system, and that one is struggling immediately, so I'm going to leave that as May. And if I type in the Sales Planner system, that's 4 CPUs. I'm just going to bump that to 8, and I'm going to say Save. So what I've done, based on the growth scenario, I've recognized that I've got CPU issues. What I'm going to do is I added more logical CPUs to those 2 VMs, and what I want to do now is it's telling me the plan is not current because I've made updates to it, so I just click on Run Plan. So what it does is it goes out and reruns the plan and shows me the results of that. Now, just to point out here, we were already in bad shape before we started, and that's why the first box is yellow. And I'm sure in your environments, right, you don't start out as bad as I started. You've got enough current capacity. It's more about what the growth scenario is. But that's why mine's yellow here. So when I look at the details, I still have the Armadillo system that's got some capacity issues. And if I look at the advice, Yep, it's telling me I still need more CPU. So let's back up just for a second and let's look at the whole system for a second. I'm going to look at the CPU utilization of the whole system, and you can see that this system's really throttled. I mean, it's running really hot. If I look at the I/O system, the I/O isn't being taxed very much at all. So if I go back to the CPU, I think we can agree that I really need to add more CPU capacity to the system, right? So I'm going to say add event, and I'm going to say change the CPU. Now I know that I've got 2 times during the year where I can actually upgrade the systems unless it's an emergency, and I can do this twice a year. I can do it the 1st of July, or I can do it the 1st of January. So I'll pick July for the upgrade on this, and identify the system here. You can see that the current system CPU hardware type is an E7 2830. So I'm just going to go out and search for that configuration, and you can see that the current number of cores that are configured is 8, and the number of threads is 2. And I can't change that because that's a hardware dependency. But what I can do is I can add more CPU capacity to this system by just adding more CPU in it from that perspective. So what I'm doing is I'm just saying, okay, so if I double this, what's going to really happen here? So I can run my result and get the output of it, and it looks really good. So based on this, everything looks hunky-dory based on the planning I've done so far. Now, if you remember back to the kind of the story that we need to support, is I've got Black Friday coming, and I need to plan for that. And during the month of November, basically the capacity requirements are going to double for the system. So I'm going to go up and add event. And I'm going to say an immediate growth because this is going to be for a specific month. And I'm going to call this the Black Friday. And again, the period of time to apply this is out in November. And I can change different scenarios in terms of the virtual machines and that sort of thing. But just to keep it simple at this perspective, I'm just going to say this is really going to double for all of the VMs on the system. And again, I'm going to click on temporary growth because I don't want this thing to go into December and beyond. So I'm just going to say it ends for this month. So what I'm doing here is I'm saying for the month of November, whatever the current capacity is I'm going to double it. So I'll say save, and I'll run the plan. So when I look at this, things look pretty good, but as a capacity planner, I don't necessarily trust the business to really be accurate. So just to look at this and say, let's add another 15% onto this just to be sure that I've got enough capacity, assuming they aren't real accurate with what they've got. So I can say run plan, and it comes up with, I've got a little bit of risk or warning basically in the environment, and goes back to this armadillo system. So that must be a fairly important system in the environment that needs to be considerably addressed. And if I look at this, it is telling me it needs a little bit more CPU capacity, but it's in the yellow and it's beyond actually what they're telling me. I feel comfortable that I've got enough capacity configured to be able to support that. Now, if you look at the last bullet that I need to plan for, is that I need to be able to add more VMs to the system, and I'll show you how easy it is to do that as well. So when I click on Add Event, I'm just going to say Add Virtual Machine, and I'm going to say Add VMs. We don't need to plan for this until January, and we'll select the host again, and I've got kind of, maybe it's just me, but I like to create a nomenclature that the VMs will be added 1, 2, 3, 4, 5, 6, 7, 8. So I need to, if I look at those in a cluster, I want to make sure what system that they're actually on. So I name them with the host name. The number of logical CPUs that I want to assign to this is going to be 2, as I stated earlier. And then there's basically 3 levels of activity, and these are some tunable type things, but there's a low, a medium, and a high workload profile. And so I'm going to take the medium profile, and I'm going to say save, and then I'm just going to regenerate the model. So what I've done in this quick session is I've been able to take an existing system and apply a growth scenario to it. I've had to make some adjustments with a couple of the VMs, adding more logical CPUs to those. I've gone back out now and I've said, well, I've got to add more physical capacity to the existing system. I've been able to plan for the Black Friday event, and now what I'm doing is I'm adding those 8 additional VMs in January. So when I look at show the results, you can see the naming conventions here of the host name and then the dash system name. You can see when those VMs come online and that there's plenty of capacity for those VMs, based on the next 4 months into the first quarter of next year. So in the example that I've gone through, I've been able to take some infrastructure, do some, maybe just an organic growth of 15%, then over the next 12 months, then I've been able to adjust it to ensure I can meet those service levels, although I realize that based on that, I need to add more physical capacity to really be able to perform that, and then plan for the specific event that I use of Black Friday, and then add more physical or some more VMs at the end of the day. So I just wanted to show you that it's, with a little bit of guidance, it doesn't take very long for somebody that isn't as sophisticated and as experienced as some of the gray-haired capacity planners like I am to be able to produce plans. So Stacy, at this point, has there been any questions?
Yeah, Jeff, we have gotten a couple of questions. So at this time, I'd encourage anybody who has questions about what Jeff has presented to submit them via the chat box. I'll go ahead and get us rolling, and then hopefully we'll get some more questions come through. So the first question that we have is, how much data or historical data do I need to build an accurate model?
That's a great question, Stacy. It kind of goes back to even when I'm evaluating data to move it from the existing infrastructure to cloud. I really need to understand the workload behaviors and pick a period of time that's representative of what's happening. So if I've got an hour's worth of data or a day's worth of data that's representative of what the application is currently doing, I can take as much as 10 minutes or an hour of data to actually do a projection on. It's all about identifying what is best representative of the workload profiles or the application that's representative of what I would want to use for a baseline, and then using that as a projection. So looking at the historical data is key to help me understand where the workload behaviors, and then picking that baseline. So the more data you have, there's some advantages to that, but if the workloads are continuing to operate similarly, and probably the more recent data is probably the more representative, because as we all know, things grow. Hopefully that answers the question.
Yeah, good. The next question is, can a negative value be entered as a growth rate? I'm guessing projecting for maybe shrinking.
Sure. In a lot of cases, as things are being decommissioned or planned to be moved, there's 2 ways of being able to do it. You can add a negative growth rate, or you can just remove that workload or that VM in some cases off the system. So you can remove things as much as you can add them, but you certainly can add a negative growth rate and start to see things change accordingly.
All right, the next question that I have is, can capacity plans plan at the cluster level instead of by hosts? And then a follow-on, and the same question was also, does it provide memory projections?
Okay, so two questions. So I picked on a particular host. In this case, I can certainly put multiple hosts that would be representative of cluster into the model and do the projections and change the workload intensities or add more work based on the VMs in that. So I certainly can look at a cluster. To answer the question about memory, we don't include memory in the model for the simple reason that memory is so difficult to measure, much less in the model. So if I look at a database memory algorithm, it's much different than if I look at a Java app or if I just look at system memory utilization on a Windows or a Unix type of a box. So the challenge that we've seen in trying to identify a general purpose model, being able to model memory is really a challenge because the algorithms of how the memory is really being utilized is difficult. So what I generally do is I go back to the performance data and start to analyze the behavior of the memory utilization and look at those metrics from that perspective, because it's considered I don't want to say inactive, but it's not an active resource. It's a passive resource that's just there. Do you have enough of it? So it's kind of a different approach to quote-unquote capacity.
Sure. Next question. Does the tool have the option to add server hardware config, example, different hardware within the VM?
So there's a couple of different ways that you can approach that. One is you can create a new hardware profile, and I didn't show that, but we do have all the hardware profile speeds and feeds as part of the underpinning support of the model. So if I had a system that was running on hardware A and I wanted to move it to hardware B, I certainly can migrate that work from the current hardware to the new hardware. So absolutely.
All right, the next question is a bit long, so hang with me here.
Okay.
What if I have overcapacity in VMs for some apps or servers that I need to release for new applications to use that are coming down the line? How does your tool handle if those servers from which I need resources back, most importantly RAM, are running databases and or JVMs, which expect that resource to be available or else they won't start? What value does your tool add in these scenarios?
Okay, I'll do my best to answer it. You threw the word RAM in there, which is memory, and I think we kind of talked about it. It's not necessarily a memory model, but if I've got existing infrastructure that I need to kind of deallocate, I can basically remove those applications. And then, those resources are available for the new applications as they come online, and I can size those applications based on, the logical CPUs, the share weights, the reservations, and those different types of things. So again, it's a shared resource. So, if those applications are not running, so to speak, and the new applications come online, they'll consume those resources. So I don't know whether I answered the question directly, but it's something that we can certainly take offline and talk about further.
Yeah, most definitely. The next question that came in is, are there limits in sizing? For example, would the tool handle 200 plus VMs per host and 5,000 hosts?
So, and that's a good question. I haven't had the experience to scale Planner out to see exactly where its limits are. I would probably go back to product management and engineering to understand exactly where the limits are, but I would certainly expect the tool to be able to support that, because as we all know, environments are large and getting larger, and so being able to support large clusters is obviously key. And so if we're not at that level right now, and I don't have the answer for that, I would expect that would be an environment that we would easily be able to support.
All right, good. I am not seeing any additional questions come through. So before we close today, I'd like to invite you to next month's webinar, where we'll be discussing how to optimize your cloud capacity. I did plop the registration link in your chat window. So if you want to get registered for that, we'd love to have you next month on that webinar. And I just want to thank Jeff today for the presentation, and a special thank you to all of you for attending today's webinar. As a reminder, the event recording will be emailed out and made available on our website in the coming days. So with that, I hope you all have a great day.
Thank you much.